algebra. These are the student challenge problems on solving systems of equations using elimination and subtraction. So I offered these two problems earlier for you to try. Hopefully you did try. Now let's work and see what happens when we work them step by step. So I could graph this equation and graph this equation on the same coordinate grid, and then if I did that, I would be able to see that they intersect in a point if they have a solution. So if I add down, nothing eliminates. But if I subtract, something is going to eliminate. So if I subtract the second one from the first one, I'm just going to rewrite them. Here's my first equation. Now I'm going to subtract a 7x. Now I'm going to subtract a 3y. Now I'm going to subtract an 11. And look what happens. When I add down, 7x minus 7x is 0, so it's gone, which is what I wanted to do. I eliminated it. And 7y minus 3y is 4y. And 7 minus 11 is negative 4. Now I want to take the 4y equals negative 4 and find out what y is. So I'm going to rewrite my 4y equal negative 4. And I'm going to use the division property of equality to divide both sides by 4, so that 4 over 4 is 1, it's gone, and 1 times y is y. So I have y equals negative 4 divided by 4 is negative 1. All right. So right now I'll say, I believe that the solution, I'm going to put a line here so that everything over here is for challenge 1, challenge 2 is over here. I believe the solution is going to be negative 1 something, and this negative 1 is going to be my x, and then we'll find our y here. So how do we find our y? To find y, so to find the y, I'm going to take y equal, or no, we already have our, that is our y, that's not our x. Have to make sure that we put it in the right place here. So now we're finding x. And yes, I did find that mistake. Did I do it on purpose? I don't know, you have to decide. Because I always want you to be able to go back and check. So to find my x, I'm going to substitute the y into either one. I'm just going to use the top one. It doesn't matter which one. And instead of a y, I'm going to put negative 1. And I'm going to put an equal sign with a question mark. I don't know if that's true or not. So 7 times x is 7x. 7 times negative 1 is negative 7. And that equals 7. Now I have a two-step equation. I'm going to add 7 to the left and 7 to the right using the addition property of equality. The minus 7 plus 7 cancels out to get a 0 because they're opposites. 7x plus 0 is 7x, and that equals 14. I don't want 7x's. I want just 1x. So I use the division property of equality, and this is gone. 7 over 7 is 1, and I have x equals 2. So I believe that 2 is my x coordinate. Now, how do I figure out if I'm right? So I'm right if, when I substitute this for my x, this for my y in both equations, they both work, and I have the same number equaling the same number. So let's take the top one. So I'm going to put a 2 here and a negative 1 here. If that's true, it means that that point is on the graph of the top line. So I've got 14 plus negative 7. Does that equal 7? 7 equals 7. You checked. Now I'm going to take my second equation. I'm going to put a 2 in here, a negative 1 in here, and I get rid of this part because it's just my original equation. So I'll rewrite it over here. 7 times 2. 7 times 2 plus 3 times negative 1. Does that equal 11? 7 times 2 is 14. 3 times negative 1 is negative 3. 14 plus negative 3 is 11. Does 11 equal 11? Every day of your life. What does that mean? Since they both checked, that means that is the solution. And if I were to graph those two lines on a coordinate grid, right where they intersected would be the point 2, negative 1. All right, so hopefully you did challenge 1 right. Now let's look at challenge 2. Why is challenge 2 a little bit harder? Because of decimals. Use a calculator. All right, so what am I going to do? I'm going to first notice that I've got the same exact y coefficient and variable in the top and bottom, so I can use subtraction. So I'm going to rewrite it. I'm going to write the top one, and I'm going to subtract the 1.5x. I'm going to subtract the 1.5y. So if I'm going to subtract it, I need to write what I just said. I'm going to subtract the 3.5, which means that makes it negative 3.5. Now, this is like the lesson that we did yesterday. These are opposites, which means when I add down, they'll be gone. So 2x minus 1.5x is 0.5x, and that's going to equal, this is gone, they're opposites, 3 minus 3.5, which is negative 0.5. All right, now I'm going to rewrite that and use the division property of equality to divide both of them by 0.5. So 0.5 over 0.5 is 1, and 1 times x is x. Negative 0.5 over 0.5 is negative 1. So I believe my solution has an x-coordinate of negative 1. So I'm going to write up here the solution that I believe is true. And I don't know what I'm writing until I check it. So I have negative 1, and I don't know what my y is. This is my x, and I'm going to put my y right here. Well, what is my y? I don't know. What do? I'm going to substitute negative 1 into one of them. Which one? It doesn't matter. Let's take the first one. 2 times, I'm going to put a negative 1 right here. Negative 1 plus 1.5y equals 3. 2 times negative 1 is negative 2. I'm going to have to use the inverse operation. So the opposite of adding negative 2 is subtracting a negative 2. And minus a negative means that I'm adding 2 to both sides. This is gone because negative 2 plus 2 is 0. 0 plus 1.5y is 1.5. And I'll use a different color here just so that it doesn't blend all together. So 1.5y equals 5. Okay? So now what do? I need to just get y. So I get 1.5. The 1.5 over 1.5 is 1, and 1 times y is y. Now we're dividing by a decimal. I recommend that you use a calculator. 5 divided by 1.5 equals 3 1/3, or 3.3 repeating. So we're saying that this ends up being 3 1/3. Any time that you have a mixed number or a fraction, the checking part is going to be harder than the actual equation. So let's do our check here. So I take either one. So I'm going to take the top one to start with. 2 times my negative 1, that's my x, substitute it in, plus 1.5 times 3 1/3. This is where it gets a little funky. What do I mean it gets funky? I've got a decimal times a mixed number, but this TI-30 will do that. All right, and then we know that that's going to equal 3 if that's on the line. So I've got -2 here. 2 times -1 is -2. I don't know what 1.5 times 3 1/3 is, but I'm going to take it, I'm going to figure it out here. 1.5 times 3 1/3, and that equals 5. Does -2 plus 5 equal 3? Sure does. That means that that point lies on that first line. And that's the reason why graphing this would be hard, because you're looking at 3 1/3. All right, so now let's check the next one. So I take my second equation, 1.5, and instead of x, I'm going to put a -1 in there. I'm going to put 1.5y. Instead of y, I'm going to put 3 1/3 there. And I'm saying, does that equal 3.5? And I know I'm getting close to going off the board, but I'm going to rewrite this. We already know that 1.5 times 3 1/3 is 5. We already did that in the calculator. I don't have to do it twice. And then you can see here, this is true. So do you see how the check was harder in some ways than the problem? So up here will be a link back to my original lesson if you need to see it. Down here will be a link to other Bear Algebra videos that you can watch if you need to on systems of equations. I'm Mr. Chu. This is Bear Algebra. I'm wearing a tie, and I want to teach you an easy way to do the math. So keep watching my videos, subscribe to my YouTube channel, and I'll see you next time in